Linear functions are a subset of functions which can be either linear or nonlinear. An explicit formula for which is w equals 12 minus L. L is the length which decreases at a constant rate, therefore looking like a line. By contrast, the explicit formula for area of a pin, A equals L parentheses 12 minus L, is a quadratic. In this case, students can and should determine whether a function is linear or nonlinear across representations or pictures or objects or equations, graphs, tables, and situations. A linear line is straight, a nonlinear line is not straight. Exploration of linear rate situations develop the concept of slope, which is a numeric value that describes the rate of change for a linear function. For example, you would use the equation y equals mx plus b. M is your slope, and b is where it crosses the y-axis. So you could say, for an example, y equals 4x plus 2. It crosses at the y-axis at 2, and its slope is 4 over 1. Looking at the figure here, if you have a width of 12 on both sides and 0 for your length, you would have an area 0 according to the area. But if you have side lengths of 6, your side length is 6, it goes all the way up to 36 because it's a 6 by 6. Before I was talking about 12 by 0, 12 times 0, your area is going to be 0. There's no room for a pin. Symbols represent real situations and should be seen as a useful tool for representing situations and solving real-life problems. For example, calculating how many cookies we need to sell to make X dollars, or at what rate do we get a given number of employees need to finish work. The equal sign is one of the most important symbols in elementary arithmetic, in algebra, and in all mathematics. However, for some students, it is a very poorly understood symbol. First, it is important for students to understand and symbolize relationships in our number system. These signs are how we mathematically represent quantity relationships. If you consider the equation 5x plus 24 equals 54, it requires students to see both sides of the equal sign as equivalent expression. So if 54 equals 54, both sides equal 54. It is not possible to do the left-hand side. However, if both sides are understood as being equivalent, students can see that 5x must be 24 less than 54, or 5x equals 30. Therefore, x must equal 6. Students may have an operational view, meaning that the equal sign means do the same thing, or a relation computational view. At this phase, students understand that the equal sign symbolizes a relationship between answers of two calculation, or the relation structured view of an equal sign. With this thinking, a student uses numeric relationships between two sides of an equal sign rather than actually computing the amount. Consider this. 7 plus n equals 6 plus 9. Since 6 plus 9 is 15, I need to figure out 7 plus what equals 15. It is 8, so n is 8. 7 is 1 more than the 6 on the other side. That means the n should be 1 less than 9, so it must be 8. Those are both ways to solve this problem for n.